actually check out what people say on YouTube. Come on, YouTube. We can do this. If it doesn't work this time, okay, never mind. We'll catch you guys later. Alright, so today it is Throwback Thursday, and as such, in the vein of this series on blinking lights for Burning Man and beyond, you know, you can use any excuse to add blinky lights to your vehicle, and I think this is a splendid thing to do for safety, for self-expression, for learning to solder and practicing building circuits of your own and stuff. It's a fantastic way to do that. So today we're going to go in depth. First, we're going to look at an old example or two of mine. Then we're going to check out some different types of switches and circuits, and also headers. And then we're going to build a new circuit for my bike, which hopefully will be done in time for dinner. I'm so excited, because the one that I've had needs a little refurb. So, without further ado, first up, we have today's Throwback Thursday feature, which is the Glowboard. The old Glowmobile, rather. Let's bring this back up. Oh no, no. Let's put it on here. Because what I want to do is challenge you to name as many of these logos as you can, and they're from hacker spaces and maker companies and stuff from all over the US and beyond, going back to at least 2010. As you can see, I've got a Maker Faire 2011 sticker from my first ever Bay Area Maker Faire. Lots of stuff from different places. Some of these places actually don't exist anymore. Some of them are just silly, and some of them are from old school nerdery. One more. We've got some of the other ones over here. Yeah, whoever can name the most of these is going to get a bunch of internet points. So for example, I've got some from Thunderbirds, which is one of the shows that I grew up on in British TV. And then the top of it is just covered in yellow and charcoal colored grip tape. This is a weird board because it's a super short board that I got from a friend. And then there's some longboard wheels on it that I got from a different friend. So it's like not a longboard, but it's got big longboard wheels and like really loose trucks. So it's like really easy to lose your balance and stuff. It's whoa. But the reason I want to show you this is because it's got ground effect lighting on it. This was actually, I think, this might have been my first ever vehicle lighting project. I'm not sure though. But what I want to show you about it is that it's got a cool double switch system. That means that not only can you turn it on, and this gives a sweet sort of nuclear effect when it's like this green light is shining off of the ground, and then you've got like the yellow and black caution tape on the top. It looks really amazing. But also you have another switch over here which allows you to switch between colors, blue and green. So you can do a blue underlighting or a green one. And this is super tough. It's been with my friend Moldover to a few different years of NAMM, the National Association of Music Makers technology show. In LA, and it still does its thing. I think he had to add something to keep the battery cover from falling off. But that's it, you know? And it's still one of my favorite ways to get around. So, that is that. I'll show you how that circuit works. So, I've drawn this over here so that I don't mess it up. And I want to redraw it for you real quick. So, there is a 9-volt battery. How are we going to do this? I didn't actually pick my colors yet, so we can do the whole thing in orange if that works. Let's get some focus back. There we go. So 9-volt battery. Boop, boop, boop. Can you see that? Cool. Nice. So the little guy is positive, and then the big one is negative. But it's really just a battery holder that has some wires coming out of it. Let me fix this focus for you. Camera nanigans. There we go. Great. Alright. So yeah, if we can actually get that a little bit better. There we go. No shadows. Now it's beautiful. Alright, so what we've got here going on is two separate switches, right? First up, there's the power switch, which is in the power line. And over here you have the LED strips, which are wired in parallel. So I'm just going to represent one of those. And you can imagine that each of the wires going to here is split in two, so that it actually goes to two different strips. There's one plus 12 volt rail, which actually runs with 9 volts just fine, and then GRB. Okay. The weird thing about these non-addressable LEDs is that they sometimes swap around the order of the pins of the rails. So like, for example, these ones say GRB, just like my skateboard, whereas these ones have power and then BRG. And I've seen BGR and stuff like that, so you really have to pay attention when you're building a circuit with this stuff. The same thing goes for if you buy generic Neopixels, like WS2812s, in an LED strip. You don't know which order the data, ground, and power lines are necessarily going to be in. So you gotta check that, always. Alright, so to connect the battery to the strips, first up we've got a switch in the power line, so you can turn the whole thing on or off. And then these are basically selectable ground rails. So you can connect just the green rail, or the red rail, or the blue rail. They actually come with a header that attaches it to a remote control system. And then, you know, you plug it into that thing. And this controls the colors, and you can like program different animations and stuff. And I've actually done that on bikes before, but for this I went with something super simple that isn't going to suck down any extra power for a controller or whatever. And then what it does is switches between green and blue, right? So I've got another switch in here, which basically gives you green and blue options. So there you have two separate switches, power switch and then the ground rail switch, which switches between two possible grounds, green and blue. And then the other thing you could do if you wanted, actually, is you could make purple, for example, if you just connected this one to both R and B. Or you could do, you know, green and red for yellow and then blue separately. But if you tried to connect just like one to all three, then they'd all be connected. So if you want it to remain switchable, you can't have, like, for example, yellow and purple, because you have to choose which one the red is going to be associated with, unless you use diodes. And yeah, it gets complicated, but it's doable, okay? So this is like switching power. And then this is switching red versus blue. Or green versus blue. And in this case, since we've got this connected now, it's green versus purple. Alright, so that's number one circuit from the skateboard. I want to talk to you about switches real quick, because this is going to feature in a couple of our other tutorials. So, I've got 3 examples here. And one of them is a button, also known as a tactile switch or momentary switch. And basically, you know, it's disconnected unless you push the button, in which case it's connected and the power can flow. This has 2 connections and 1 actuator. These 2 connections are just going to be connected or not. So let's take a look at this sweet tutorial from SparkFun by someone called Jimbo, which talks about pulls and throws for switches. This is the notation that tells you what your switch does, basically. So the button I just showed you is a single pull, single throw switch. And that means that it has 1 actuator. It's got 1 circuit. And you're just connecting it or disconnecting it. Perfect for on-off switching, etc. So this is, you know, a switch, toggle switch version of what I just showed you. Yeah, and so next up you have a single pole double throw switch. And I'm going to show you an example of that. Looks like this. So again, you have 1 circuit, but it's being switched your middle thing is what's always connected. So that would be connected to power, for example. In this case, you have one connected to power and one going to your 12-volt line. See, power to 12 volts. And then it's disconnected unless you push it together. In this case, you would connect the middle contact to power, and then one of these side ones to 12 volts. And so in this case, the middle one and that side are connected, and in this case, the middle one and this side are connected. So you're basically choosing to connect to one of the others at a time. And that is called a single pole double throw switch, because you have two options for what you can connect. But it's still all one circuit, right? You're throwing one thing at a time. Or no. I always get this confused. Anyway, so this is why I have to review this as well. So in this case, you can also use this as a power switch. All you do is connect the 12-volt source to this guy, or 9 volts or whatever, and then this one you connect to your other side of, the LED strip or whatever, and then this one you just leave unconnected, so that in this case, the switch is up, so it's connected, and in this case it's disconnected, so it's off. Yeah. And they talk about that in this tutorial. So then you also have things like pole double throw switches, which basically gives you two separate circuits that you can control. They don't have to be separate. You could still have multiple things connected to the same power line, but you have the option of doing two separate circuits because you have two separate sets of contacts. It's basically like you take this guy and you put two of them side by side, and then you connect the two switches together, the physical switches, so that if you push it one way, both of them get switched to the same direction, and if you push it the other way, both of them get switched to the other direction, so that they're controlled simultaneously, but they're two separate switches. They've just been glued together. And that, in that case, that is a double pole, double throw switch. And what I actually have is a triple pole double throw switch, which I use for bike circuits sometimes because of reasons that I'll tell you in a second. But basically what you have here is 3 of these switches glued side by side so that you can have, one power source here, and then, 2, either like your power to your LED strip over here and nothing over there, so it like turns it on and off. And then actually you can have a whole other separate power source powering another set of LED strips, and then you turn it all on at the same time, which is why I like this for bike lights, because you have a lot of flexibility. You can make like a red circuit for tail lights, and then another circuit for the rest of your bike. You can leave the tail light power source separate, which means that it's probably going to last a lot longer. And even if your other lights eat up a lot of power, you're not going to be in danger of going invisible and getting hit by something because your tail light is out, So I see it as a sort of safety / power saving measure to have those on separate power supplies. Plus, this is a really fun switch to work with. I usually put this underneath the seat because there it's protected from, most debris and rain. But San Francisco doesn't have a lot of water, so I don't have to really super waterproof stuff and protect it from the elements. All right, so, X pole, Y throw, you can go at any number of whatever. So this is a SparkFun tutorial that I will link underneath this video in the description and also in my project. Oh, a little bit more info about the skateboard I showed you. It has a storied history going back to 2010. Originally, it was a guitar that I made with rubber bands and an Altoids tin and a piezo pickup that went into this amp that I had. And it's really terrible. Oh boy. Also, my video skills were not, the best. This is, again, from 20... Okay, you can't even see anything there. Oh! No, you can't see anything. But yeah, that's what the skateboard originally was. And then you can see... Getting some weird... someone's trying to call me. No! Can't take it right now. You can see my friend Kyle doing a handstand on the Glowmobile, and for some reason some bras. And then also some different versions of bike lights that I've done. So this was one case where I had separate circuits for the blue and the red. So the blue was sort of an optional thing, and then I could go into stealth mode and just have the red safety tail light on there. Did a different version of this where I added some green lights around and rings around the front. It looks a little tacky with the red, green, and blue, but it's kind of cool too. And then here I had 3D printed a case for the 9-volt batteries and done just like, I think this might have been actually remote controlled. And then you've got the Glowboard or Glowmobile up in front with the skateboard. So coming now to the present day, let's look at some more circuits, alright? So I talked briefly before about Neopixels, and you can find that in the previous video that I made about this. Where is this? Ah, here we go. The Blinkin' Lights video at the top of this tutorial. And so I talked about Neopixels a bit, which are used in the Merlin armor, which is controlled with an Arduino controller. There's also another set of Arduino-controlled LEDs that are done with an @tiny chip, sort of directly, and those are Neopixels again. But what I'm going to be doing for my new bike, I think, or rather, a new circuit for my existing bike, is going back to the basics and doing the same kind of thing that I did on my skateboard before, which is these regular non-addressable lights that run off of 9 or 12 volts. And then there's some circuit examples in here, but I'm just going to go through my current design strategy and we'll see the whole thing from start to finish. So, we talked about switches, we talked about the Glowmobile. Next thing I want to do is look at, what do I want to do? Yeah, I'm going to show you the circuit that I'm designing. Okay, so this time I want my bike. This is the way that I prototype or design biking systems. So here's your thing, here's your fork. This is a super crude drawing of a bicycle. First you just want to start by like sketching what it looks like, right? I've got these drop handlebars, I've got the top tube, the bottom tube, this thing coming down, the seats here. You've got the back fork and the wheel there. I usually don't even bother putting on the pedals or the wheels. I do have the rack here. So let's see, what do I want to do? I think what I want to do in this case, I'm going to do purple for red. This is the way I usually sketch it out. I'm going to have the controls mounted up under here, and then I'm going to have a red fork here. And then the blue lights, I want to have a separate circuit controlled by a separate 9-volt battery. And then I might actually do green and blue, like a cyan color, because it's pretty and because it's brighter. So I can do like super powerful mode, and that's going to come here and go in a sort of linear fashion like this, down there, back up here, and then I think it's going to go under the rack, because why not? I can control a ton of LEDs with this thing. But what I also want to be able to do is switch that to red if I want. So the way that this is going to work is, like that's my physical design, right? And then my circuit design is going to come like this. We're going to have the 9-volt battery. What's the best way to do this? I'll just do it like this. Okay, so plus and minus from the battery. I'm going to have a switch in the power line for the red circuit. Remember, that's my tail lights. And these have 12 volts BRG. Okay, so plus and then BRG. And then that's just going to go to red. So that's circuit number 1. It's very simple. And then circuit number 2 is going to go like this, where we have the 9-volt battery, and then we have the strip over here, This is a crude representation of what the contacts look like that you solder to. So plus B, R, G. It's a little inconvenient with these ones because the blue and green are not next to each other, but that'll be fine. So again, I'm going to have a power switch here. And since I'm using my, what is it, triple pole double throw switch here, I'm going to have one circuit be the red, one circuit be the cyan, and so that means that these two are the same switch. They're just going to be right next to each other, okay? I'm just using one controller there. And then what I'm going to do is have a red line and a cyan line, which connects both the green and blue. Maybe I should do that in a different color entirely, in fact. Haha. There we go. Okay, so then this from the ground line is going to connect to either one of those. So either cyan or red. So I'm going to have another switch in here to do the colors. So basically I'm going to end up with this guy doing the power, and then separately a color selector. And that's basically exactly the same thing that I had on the skateboard, except that I have two separate circuits. This switch, instead of just being a power switch for this one, there's also like another one running on the same power switch that's just red. Alright? But this is, they're basically going to be friends. They're going to be right next to each other. And then this is how I'm going to mount it on the bike. Now, the other thing that I've had to do is make some measurements on the bike itself to make sure that I can cut it to the right lengths. When I finally assemble it, I'm going to do it on the bike because I'm going to have to run this around bits of the bike with regular speaker wire because I don't want to just wrap the LEDs around because that looks tacky. So in these places, I'm going to just hunker down next to the bike with my butane-powered soldering iron, which I don't actually have with me today, so maybe that'll have to be another like later thing. But and solder those directly onto the bike while it's laying on its back. The other thing that I've had to do is measure these lengths in order to make sure that I can cut the right amount of LEDs to make it look nice, but also not like crash the ends into the metal, because that's bad. You would either have to like smush your strip, which would make it kind of wavy, or like, you know, you'd end up like doing something really terrible with like potential shorts with the bike frame, which is bad. I mean, shorts and biking go together, but electrical shorts and biking do not go together. Not that kind of bike shorts. We don't like that. All right. So this I measured is about 18 inches long. This is about 20 inches long. And this is about 16 inches long. And I'm going to have to measure the bike rack. But basically what this breaks down to is that my LEDs come in these sections that you can cut apart, like so, just right down the middle of these contacts. Let me zoom in for you. Or focus in. There we go. Yeah, see this little scissors icon? That means that you cut down right between those, just like with Neopixels. And so each of these sections, you can't subdivide it. If you cut in here, then it's going to not work. But if you cut down the middle here, then you can solder and it'll be all happy. So each of these is 2 inches long. Let's double check that. It's the same as 5 centimeters. So, yeah, 2 inches. Oh, I need to actually be where you can see. Yeah, see that? And then if we flip over the tape, we've got centimeters. Same deal. Really handy little conversion to know. Which means that basically I need to, I like to measure these lights in sections, which means that this will be 9 sections, 10 sections, and 8 sections. So I can just go ahead and cut those. 1, 2, 3, 4, 5, 6, 7, 8, 9. An interesting feature of these strips, you might notice, is that they, especially the cheaper ones, may be made up of multiple smaller strips that have been attached together. This is your standard sort of 5 meter, 15-foot strip roll. And yeah, you've got a place here where it's been spliced together at the factory. And then the epoxy coating that's waterproof goes over that. So that's kind of interesting. Let me double check the length here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, cool, yeah. Then I need one that's 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoa, these ones must be really cheap. Because not only is this adhesive coming off in the middle of the roll, but also it's got 2 more splices in just this section. Wow. Plus the epoxy coating is not super regular. Plus it's the 3M adhesive backing is not super well secured. But I have extra backing tape that I can add to there. So okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not concerned that much about the backing because all I use it for is to temporarily mount the LED strip onto the bike while I prepare to hot glue everything and solder everything together. So there'll be other things that I add to attach this to the bike, including hot glue and electrical tape. 1, 2, 3, 4, 5, 6, 7, 8. Wow, another splice. These are so cheap. Wow. So that is like the main part of my bike that's going to be cyan and red, switchable. I do still need a piece for the rack and then a couple pieces for the fork. So I'm going to measure those real quick and I'll be right back. Okay. Based on the arrangement of things, I've decided to omit the bike rack. Because sometimes it's really annoying to go around extra little protrusions and stuff. If you want it to be really flush with the body of the bike, which is what I want, and that's actually why I'm redoing my lights, because the old ones are this like Neopixels and silicone tubing thing, which really doesn't look nice with the frame of my bike. I'd rather have something that's not addressable and just mounts really, really flush. So that means 4 sections for the tail lights. For each of them. So let's do that. Here we go. 1, 2, 3, 4. And 1, 2, 3, 4. Man, these are gonna last forever. If you have a lot of lights on your bike, then it will probably last about a month on a single 9-volt battery. The other thing you can do though is get like a USB rechargeable hub, some of which will provide 12 volts via a barrel jack, and I actually want to work with that because it's rechargeable, and obviously it's better to not be throwing away 9-volt batteries all the time. So what I might do actually is run the main body of lights off of a rechargeable hub, and then have the tail lights run off of a 9-volt, because it doesn't really matter if the 9-volt gets stolen. That's another consideration. You want to make sure that you use stuff that you can sort of put away. I've considered putting like a controller and a battery hub inside of a bottle in the water bottle cage. So like, for example, you would cut off the top of this, or ideally have like a refillable water bottle with a large cap that you can screw off, and then you can 3D print a topper for that the wires can go through. And then you can just like remove the bottle with the batteries and the controller and everything, so it's not a target for thieves. They normally don't target these LEDs because they don't look super expensive, especially once they've gotten older, and so they're a little bit more yellow. This silicone coating can yellow over time, but it still looks pretty good. This is like a super old set that I made as a demo. In fact, this is another example of my skateboard circuit. See how you've got the switch in the power, and then you have the ground line being split between blue over here and then yellow, which is a combination of red and green. There's just like some solder that's been sort of daubed across that connection there. So green and red are connected to make yellow. That's one color option, and then the other one is blue. You have the ground connection in the middle of the switch, and then you can switch between them. That's basically exactly what I'm going to be doing now. So exciting! Only these are going to be, yeah, again, there's going to be another separate LED strip coming off over here. Alright, so let's start soldering a little bit of this control system together. And as long as I can get, let's see, I want it to go to the 9 section first. Which one is that? This one. If I can get the control system set up with the first couple of switches and everything today, then that will be fantastic. Okay. And then basically I'm going to run wires to connect each of the rails to each of the other rails to put these end to end. So we need some wire. Ideally I'd be working with ribbon cable because it can handle the amount of power that we're putting through it, and also is sort of durable and pretty flexible, which are all virtues, but sometimes that doesn't work out. Okay, so actually I have 2 different types of 9-volt connectors. Let's go find one that matches. There we go. 2 matching ones. So both of these are going to go to middle connections on here. And I'm going to bring this down so we can see a little better. Perfect. Let's get this out of the way. I'm going to have this mounted in one place under the bike seat, and then these guys are going to be in another place under the bike seat. So I want to give them a little bit of wiggle room. I'm basically going to give them the maximum possible, just leave these at their original length, and attach them to 2 of these central connections. So let's turn on my soldering iron. I'm going to actually fashion these into little hooks, which helps them stay in place while I solder, and also makes the connection a little bit more robust. See how that's a little hook now? Same thing with the other guy. And then remember, this is like 3 of these switches mounted side by side. So I'm going to put each one of these in the center of one of these switches so that it can either be connected to the rest of the circuit or not. Cool. All right. So this is going to be at the front of the seat, and this is going to be at the back of the seat. The next thing I need to do is connect my LED strips. This guy will be super easy. It just connects to a red strip, but it's going to end up splitting in two in order to connect to the tail light. So what I'm going to do here is make a splice. Do I want to use this wire or what? Yeah, I'll stick with this. I'm going to make this pretty long because it needs to go a ways to get to where I'm putting the tail lights. So let me double check the length on this. There's a lot of like running back and forth between the bike and the design. Except of course once you start like actually connecting the stuff to the bike. Okay, so that should be pretty good. I'm going to make these wires red because I want to know that's where they're going. Ooh! Sorry about that. I'm stripping the ends here. And I'm going to hook both of these guys up to the ground wire. I mean, it's a little confusing to use red here because it's not the power line, it's the ground line, but I think it'll be fine. I'm going to have to connect all three of these together, so I'm going to grab some heat shrink tubing, which is good for insulation, and grab a sort of moderately sized piece, cut it down to size. So this is just going to cover that splice connection. I'm going to tin all the ends of the wires that we're connecting. So let's put this guy, no, let's put these two into my third hand. Doop, 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 doop. Oh, yeah, let's actually get them close together. Oh, no, too loose. Grrr. Connect! Okay, let's put down the soldering iron for a sec while I wrangle these into position. Come on! That might be as good as we're gonna get. Alright, that should work. Big glob of solder on there. Okay, now here comes the rest of our circuit. This guy. Oh, you know, oh, ah, beautiful. Okay, so glob some solder onto there. Glob some solder onto the other wire. I think it's already pre-tinned actually. Okay, and now I'm going to slide this piece of heat shrink over here so that it's all ready. And I can slide it down onto the joint once I've soldered these together. Cool. That could be a little smoother. Let's just make sure that that's a good connection. I don't want to reheat this too many times because the flux goes away and then the solder becomes brittle. But I think that's pretty good. Okay, cool. So now what I'm going to do is slide the heat shrink over the joint. I could actually have used something probably smaller, but this is what we've got now. And I'm going to cover it up and then use my lighter to shrink the heat shrink onto the joint. And that should protect it pretty well from the elements. Cool. Can I shrink that a little more? Close enough. Alright, so now I have these two, which can go to my red streams on my two tail light pieces. And by streams, I of course mean rails. Let's see. So in order to solder to these guys, you see how they're covered in this waterproof silicone epoxy? Basically, I've just got to peel this, the circuit board that's flexible, back from the silicone. Come on. Just gotta get it started here. And I wouldn't worry here about taking the circuit apart because it's fairly durable. It's not like super durable, but for this... Oh no! Am I lying? Is it actually coming off and sticking to the silicone? No, I think it's fine. But I can sort of switch to getting my nail in there. There we go. See how that's detached? Now I can just snip that off with my side cutters and expose the solderable pads. I'm going to do that again. Make sure that you're, even if you have strips that can be powered from either end, test first to make sure that it can be powered from either end, or whichever end you're going for, and then make sure that your two strips are going the same direction. Wow! These must be so cheap. They even have different fonts on them, I think. Like this font is a little taller and this font is a little shorter. Wow! Or maybe it's just stamped more heavily. Okay. You can also go from the silicone side to start with epoxy. Come here. Come apart. This part's being a little more annoying because it's one of those splices, so I think the epoxy sticks a little bit better to that. There we go. Okay, cool. I always think these look like little elephant feet. Like boop, 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 boop. Alright, so these ones are nice and pre-tinned because I had to cut along a joint. So, but the other ones aren't, so let's do this. And to tin these, I'm just going to focus on it for you first. Yeah. Put a little bit of solder on the iron for thermal contact. And then just try to make sure you're covering the whole thing. Some solder pads have little ovals inside of them that are disconnected, so make sure that you cover the whole pad. And now I'm going to tin my little wires here. You really don't need much protruding out from the end. You don't need to strip much of your wire. Oh! I'm going to need to apply voltage separately. So this is going to the red line on there, and then likewise on here. Yeah, so I guess I'll just hook up the tail light for now, and then you can sort of extrapolate from that what the other one looks like. because this is going to be a lot of soldering. When I run this as a real-life workshop, it takes about 4 hours to get everyone doing their thing, and that's with about 10 people. So let's see. I need 2 more wires. I'm going to do another splice. And basically that's going to take... We're going to do a little bit more matching, okay? So here we have the ground rail connected. It splits and it goes to my 2 little circuits. And then I'm going to run a power line from this other pin on the switch. Because this basically means that this is going to be the on position with the middle pin connected to that side pin. And then this is going to be the off position with the middle connected to nothing. I'm not going to put anything here. But I have to make sure when I'm wiring this up that when I do the other LED strip, its on position is the same. So they'll both be on this side or both be on that side. But otherwise it'll be this weird switching situation where I either have the tail light on or the main body lights on, and that would kind of suck. So yeah, let's grab some more wire. Make it the same length as the other stuff. Approximately. A little longer. Okay, cool. And then I need a little extra space because we've got a few extra inches coming from the switch. So let's see. Maybe about that. Wait, no, because this is going to start around the same place. Batteries go in the back. Okay. And then that goes down the body of the bike. Okay. So it's going to want to be like this. So I need 2 pieces again, about the same length. Ooh. I'm just folding this in half before I cut it. Oh. There we go. If you're just joining us, then skip to the beginning of the stream and you'll see some cool things that will explain all your questions, ideally. I'm going to strip these ends of this wire. And once again, to connect these to the outside pin, I'm actually going to connect them both just directly to the switch because there's no point in spending all that extra time to make a splice when it's easier just to attach them both to the same little loop. So I'm going to make 2 more little hooks on here and sort of squash them down. And I'm able to do these hooks because this switch happens to have little loops as connections, whereas my other switch has only little straight pins, so I'd have to like lay them all side by side and solder them that way. Okay, so let's choose this side, hook these both into here, like so, and then I'm going to solder it all together. One trick that I do with my solder is that I just pull it all, pull a bunch out of the roll, make it fall over. That's really great. It's a good technique. And then just stand it up like that, so then I can put my hands in here, hold everything in place, and bring the soldering iron in from the other side. No fuss. No muss. Neither fuss nor muss. Just gonna glob a bunch on there. And eventually what I'm gonna do is add a bunch of hot glue, which will waterproof and electrically insulate and physically reinforce all of this. Trying to get not too much up in the space of the other part of this circuit. Okay, cool. So now that's connected. I'm going to connect these to our little strips for the tail light, and then we're going to see it ideally work. So let's get this all straight. and it's curling around my camera now, which is not optimal. Okay, okay, okay. So we have the switch over here. That's going to be at the front of my bike seat underneath. I have the other circuit connection here. The batteries are going to be at the back of the bike. I've got the power connection. And then basically these are going to connect all the way down to my fork lights. Oh boy! There's a lot to keep track of. Gonna strip these. I probably stripped them more than was necessary. Let's cut those off a little bit. There we go. And now I'm gonna solder these, after tinning them, to the power rails on my LED strips. And I did this in a really confusing way, where I did the ground in red wire and the power in blue wire. Don't ask me why. I thought it was a good idea. That's clearly very strange. All right, so here we go. Ooh, that's actually already ripping off. Oh no. Can be kind of fragile. You want to reinforce these circuits as soon as possible, especially if you're using solid core hookup wire, because the pads want to rip off. You can avoid soldering altogether if you use these little sort of snap-on, click-in connectors that they have, but I've heard from friends who tried those that they're not very durable or stable, which is kind of what I expected. Sorry, guys. Yeah. So, let's try hooking this up and see if it works with the battery. And sadly, I'm probably going to have to swap out this strip because it looks like that connection's already getting torn off. Yikes! Much faster than I expected. But that's because this is inflexible solid core hookup wire. So we have these two little twins here. I'm going to hook up their battery. Gonna stick this in here. And ideally, what we're going to get is... Oi! Ah, yes, good. Both of them still work. So as long as I reinforce that one guy really quick, it should work fine. And then here's the off position. On, off, on, off. Cool! So now I can wind these around the body of my bicycle, mount the batteries and everything, and we'll be off to the races. Next time, we'll cover the other part of the circuit, which is this version, which is just the same, except that I'm also splitting the ground wire into two possible color combos. So that's going to be a cyan color and a red color for low power / stealth, because stealth is awesome. Alright. And also sometimes you're biking through the woods at night and you want to not get hit, but also you don't want to totally wreck the ambiance for your friends, which is nice too. Alright, have an awesome rest of your Throwback Thursday. Wow, it's been a long stream. And I hope that you learned a thing or two and that you get to spruce up your own bicycle, skateboard, whatever. We'll catch you soon. Ciao.